In this video, I'm going to show you how to run a one-way analysis of variance with repeated measures. Here I have collected data of 52 employees, their monthly average output before a training program was administered and mid the training program and then after the training program, of which I want to compare these different time periods to see if there's any significant difference in their average output across times. Then I need to run a one-way analysis of variance with repeated measures. To do this, I click on Analyze, then I click on General Linear Model, then click on Repeated Measures. Now, the factor in this particular case is time. Remember, we are considering differences in time across 3 different time periods. So I'm just going to use a name that I'm going to remember. So I rename that to time. And then we're considering 3 different time periods, so that is 3. I'll include 3 in this particular field, and then I click on Add. And for the measure name in this particular case is our dependent variable, which is output. So I'm going to type in output in the measure name field, and then I click on Add. Once this is done, I click on Define, and in the Define field I'm going to move all of the outputs across the different time into the within subject variables. So I move output after the training, output mid the training, and also output before the training. Next, I'm going to click on plots, and I'm going to move this time into the horizontal axis field. I click on Add, and then I say Continue. Next, I'm going to click on the EM means. The EM means I'm going to move overall into the display means field and move on time into the display means field. And once I'm done with this, I'll check the compare main effects box. Once I'm done with this, now I click the drop down Bonferroni in order to be able to see the interaction effects, the comparison effect between the 3 different time scales. Once I'm done with this, I click on Continue. Then again, I'm going to click on Options to select some other statistics. I'm going to click on Descriptive Statistics and also Estimates of Effective Size. And then again, if I want to change the significance level from 5% level of significance, let's say 1% level of significance, I'm going to do this here. But I just want to leave it at that. And I click on Continue. Once I'm done with this, I click on OK. SPSS is going to run the analysis and give you the results in the output view. But I must warn, you will be overwhelmed with the multiple tables that SPSS is going to give you. But I'm just going to concentrate on a few of them that are important. So first, we look at the descriptive table. This gives us the mean of all the different outputs across the different time periods, and also the standard deviation and the number of samples in this case, which is 52. The next table I would like to show you is the test of within subject effects, which helps us to see if there is a statistically significant difference of the different outputs across these time periods, across the 3 different time periods. Now I'd like to state this. Now there is an assumption of sphericity, which most of the times a one-way analysis of variance with repeated measures is going to violate. And to make up for that violation, we interpret the test of within subject effects using the Greenhouse-Geiger adjustment. Looking at this, we see that the F statistics is 2964.605, and this is statistically significant at 5% level of significance. We see here that the p-value 0.00 is less than the 5% level of significance set. What this tells us is that there is a significant difference in the average output of these employees across the 3 different time measures. Then again, the next table I want to consider, which I'm going to show you right now, is the pairwise comparison. What this helps us to do is that we can be able to compare the interactions between the 3 different time periods with each other. So remember, the first time period we have is before the training. The second time period in this case is what mid the training, and we see here that when we compare the outputs before the training and mid the training, we see that there is a statistical significance difference between the both of them. And also when we look at before the training and after the training, we also see that there is a statistically significant difference between them. And that is the same way it is for mid the training and before the training, and so on and so forth. So this is how to run a one-way analysis of variance with repeated measures in SPSS. In case you want to learn more about how to interpret the one-way analysis of variance with repeated measures, why not sign up for our Research and Data Analysis Masterclass? Thank you.